them out in his works. So as he says, these then we assume to be the original elements of fire and other bodies, but the principles which are prior to these, deity only knows, and he of men who's a friend of deity. Anyone who can point out a more beautiful form than ours for the construction of these bodies shall carry off the palm, not as an enemy, but as a friend. He who disproves what we are saying and shows that we are mistaken may claim a friendly victory. In other words, if you look closely, he's hinting all the time at a deeper esoteric occult doctrine. That's at Timaeus 53a to 54b. Now we know from his nephew Speusippus, who took over the academy when he passed, Aristotle didn't get that role and went on to create his own school, the Lyceum. But in Speusippus's writings on Pythagoreanism, of which we do have some fragments, we find that there was another triangle, an equilateral triangle that's not bisected, that represented unity, the one. The one that's missing is the one that creates the dodecahedron, the cosmos. You have the four elements, but then the fifth one has 12 faces, and those are pentagons, but then the key is to figure out what triangle is in that, and to do that you have to figure out the golden ratio, the golden section, and that was absolutely forbidden because that was the great key of the mysteries that was revealed in initiations. And so we see, as I was saying, 1, 2, 3, but where is the fourth, my dear Timaeus? And there it is. Now, when you take the Platonic solids and nest them together, which is what Euclid did in the 13th book of the Elements, you find that when you put the icosahedron, and those of you who come through the gates into this building, you realize there are two pillars, and on the top of them, Claude Bragdon put an icosahedron and a dodecahedron. It's all golden ratios, and we're going to talk about Claude Bragdon tonight too, for a very good reason. So when you nest inside the cube, earth, you put inside water, the icosahedron. When the edge comes up against the face of the cube, if that is equal to 1, then the length of the edge of the cube is phi. That's the Greek letter phi, which means the greater, which means the golden ratio. There's a greater, larger way of looking at it, but then there's the lesser that we'll see, which is 1 over phi. But we'll see that later. So if you do a similar thing, and you take the icosahedron and put it inside air, the octahedron, it's a little different now. The vertex comes up and cuts the edge at the golden cut. That's been kind of missing a little piece there. That's the letter phi, or should be. So that's the golden ratio is to 1. Likewise, when you take the icosahedron and you take an edge, if that's 1, and then you run across to the other side, you'll find that that's exactly phi, and you create a golden rectangle. In fact, there are 3 golden rectangles intersecting at right angles in there. Now, according to Plato, the one in the indefinite dyad, now this is the key. The one is the good that we find in the Republic, but he could not tell us exactly what the indefinite dyad was, which he spoke of as the great and the small, the more and the less, are the principles of all things, and even the forms themselves. In other words, there's 2 principles behind all of creation, the one in the indefinite dyad. And to figure that out is to figure out the mechanics of creation itself. Thus, Simplicius records in Alexander's commentary on Aristotle's now lost books on the good. What was called on the good, or the good, is the one in the academy. And there are others, as you see, who also wrote these down. But notice they also maintain that Plato's comments were enigmatic in themselves, even when he would give the lecture. He had to continue to hide things. He was greatly criticized, by the way, for revealing the mysteries of Eleusis, Samothrace, and the Egyptian mysteries. Now here is the primordial, the first scission. You take a line and you cut it in such a way as you're going to see you get proportion. Now some of my slides, for us to get through all of this, I may have to run through some fairly quickly, but let's take a second with this, because this is the foundation of all trinities. So you have the whole line, which is the greater, and we're going to say for the moment that that's big phi, 1.61803339, or roughly 1.618. You golden cut it, and you're left with little baby phi, which is 1 over phi, which is 0.618039. Exact same number, minus 1. Here's unity. So the 1 becomes the geometric mean between the lesser and the greater. The 1 and the indefinite dyad, the more and the less. More than what? More than 1. Less than what? Less than 1. This becomes Vishnu. This is Brahma, this is Vishnu, this is Shiva. This is the Father, this is the Son, and this is the Mother, or however you want to look at it. In fact, the philosopher-mathematicians at Alexandria were the ones who taught the Christians how to create their Trinity. Now, of course, anytime you have a flower, most flowers are pentagonal. And there's a very good reason, because anytime you have a pentagon, you have a pentagon, and inside you can inscribe a pentagram. Anytime you have a pentagram, this whole line, when it's cut here, this could be the greater, this could be the lesser, and there's unity in between. But it fractalizes, and that's how nature works. All of nature is holographic, fractalizes from top to bottom. No matter how big we're looking or how small, you find the same pattern, scale independent, running through everything. So furthermore, if you take this portion here, that's the golden cut. This is the longer segment, this is the shorter. It continues to fractalize using the golden ratio. So here's how it works. The whole is to Plato's upper intelligible world as that is to the lower sensible world, as the world of forms is to the world of mathematicals, as everyday objects in our world are to the artifacts, if we know what we're doing, we create in art, in architecture, and so forth. Now here's the original drawing that I did, and I've kind of animated, and you'll see in a second. But I want you to notice when I go through this, there'll be an angle that goes up like this, and it's going to be 26.5 degrees, and that's going to come up later, and it's very important. So here's how you create a golden rectangle. You take a square, you bisect it, you cut it in half like that. You take the diagonal. There's the 26.5 degrees I was mentioning, which is so important on the Giza Plateau in Egypt, in the pyramids. Now, I didn't have the move where I could arc down, but you can see the line. So you come down there, you extend the line out that distance because you've taken your compass, point here, point there, arc down. And you now have a smaller golden rectangle in yellow, but the entire is a golden rectangle. And then from this point, in your compass here, you arc down, you cut this line in what now is the square root of the golden ratio. I drop that down there, so that's a square root of phi, or square root of the greater if you wish. That is the greater, that is the lesser. That's 1/2 of square root of 2. Now, that's the only approximation in there. The others are absolutely exact. In other words, this is the matrix, the womb out of which the other ratios come. So here is root 3, here is root 2, and those are exact. And then furthermore, you'll see how the square gets built up, these kind of faint lines. So there's your squares and cubes of nature. And here are your equilateral triangles, which make up the other 3 Platonic solids. The only one that's left is the one with the pentagons, which is all involved with the golden ratio. And so simplifying it, there's the greater, there's the lesser, square root of the greater, 1/2 root 2, root 2, root 3. I've called that the golden chalice of Orion. Now, what George Henry Felt was doing is something fairly similar to this, to nest the different ratios in a diagram that could be used by architects and artists, scientists, to figure out the secrets of nature. Now, the last time the golden section book was done, it was Divina Proportione, done by Luca Pacioli, who was known as the monk drunk on beauty. And you see in the corner here, you see the dodecahedron, you see a Archimedean solid. By the way, there are 13 Archimedean solids. 5 and 13 are what kind of numbers? They're both Fibonacci numbers. We go 5, 8, 13. Now, I want you to notice something. 8 is to 5 is basically the golden ratio. 13 is to 5 is the golden ratio squared. You're moving up another octave, so to speak. And here you have from Pacioli's book, which I got when I was in Florence. And here you see a pentagon, and you see the golden cutting of the line with that diagonal. And as it turns out, the illustrator was none other than Leonardo da Vinci. And much of the Renaissance that occurred was, yes, Marsilio Ficino and the translations of Plato and Aristotle and Plotinus and the Hermetic teachings, but it was also the mathematical recognition of the ancient Greeks and Egyptians, and that's the whole thing. We're on the verge of another Renaissance, unless we proceed to go down the tube first. And here are your five Platonic solids here. Again, this is fire, this is air, this is earth, water, and there's the dodecahedron, and that's the one that represents the cosmos. And here are your 13 Archimedean solids. One that's very significant here that I'd point out is the truncated icosahedron, where you cut the corners off the icosahedron, and you'll find that you get a pentagon surrounded by 5 hexagons. And of course, that led to the Nobel Prize in chemistry in terms of another form of carbon. Now, here's your icosahedron, dodecahedron, out on the pillars of the Theosophical Society. And when you intersect, we've already seen this with the icosahedron, but when you take the dodecahedron, the points go to the center of the faces. That's why these two are duals of each other. They fit perfectly within each other, and it's all golden ratios resonating. Now, one of my important mentors or teachers was David Bohm at Birkbeck College at the University of London. I realize that I think that sound gets cut a little bit if I don't keep this here. And here's what David Bohm said, really important, and this is in The Undivided Universe. The essential features of quantum interconnectedness are that the whole universe is in some way enfolded in everything, and that each thing is enfolded in the whole. Our topic tonight is how that enfolding occurs. That's what we're talking about. It is the secret of as above, so below. There's got to be a mean that links the above and the below. That's why you get trinities. There's an intermediate factor that bonds things together. So on the cover of Scientific American, you can see, are you a hologram? Quantum physics says the entire universe might be. Not only might be, that's the way it looks now. The whole thing has fractalized, and to fractal is to fracture. And it fractures through golden ratios from top to bottom. So later when we see the quarks, you will see that the quarks, which are the foundation of subatomic particles, are themselves resonating at the golden ratios. They're different functions of the golden ratio. And so the universe itself, as we see on the cover of New Scientist, is fractal. And so we see in this particular vegetable